pretty ugly.
All right, different integral, Riemann sum, different integrals. Okay, so watch. Okay, left endpoint, right endpoint. The function here, from 0 to 6, partition in interval from 0 to 6 into 4 subintervals. There it is right there. For which subintervals? Here. So there's a couple things I want to show you. Like, there's a formula for this, but I suck at doing formulas. I really do. Okay, so instead, I make the formula every time. And if you think of it like that, it's, if you make it, you understand where everything's coming from and where it'll go. And a lot of things like this. And this is one of them. Okay, so let's see. Add 0 to 6. Hold on a second. 1, 2, 3, 4, 5, 6. Okay. And it goes, I don't know, up somewhere. Blah. Something like that. Yeah, it's going to go up pretty. Anyway. So we have some values here. So I know at 0, let me see, plug in 0, I have -3, right? Yes?
Yes.
0, I get -3.
9.
Okay. At 1, I have 2. -2 or +2? And at 2, +1. And at 3,
Yeah.
4/6. Okay, so I'm going to pretend like I actually did a lot of this. All right, so I'm going to go here.
Wait, there's no fool right there. Hello. 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 Is that me? Graphic designer problem. Oh boy, did not foresee this problem.
I've foreseen it.
You did. You called it out. You're like, it's gonna go really. You still did it.
Okay. So, yeah, like, okay, let's perpetrate like I knew I was doing at first and have like a real graph there. All right, so instead, so for this right here, if we're doing left endpoints, that means I'm going to have rectangles here, right?
Yes.
Riemann sum is rectangles.
Yes.
Trap rule is trapezoids. Okay? So we're going to do a left endpoint. So it's going to be the value of the left endpoint. So let's take a look. So for this one right here, it's going to be a rectangle. What is my width from here to here?
1.
Okay. So from 0 to 1, 1 to 2, 2 to 4, 4 to 6, right? So it doesn't say equal. It just says these endpoints here, right? Okay. So for this, I'm going to have this information. The left side, as I plug in 0, I get a value. So it's going to be, this is my delta x. Okay? So that's going to be the width that I'm going to have right there. And if it is a equal portion, that makes this math a whole lot easier. But it's not. They're not. And so each one's going to be individual rectangles, isn't it? Okay, so from here to here, my delta x is going to be 1. So it's going to be base times height, right? So it's base, which is going to be 1, times my height, which is f of, what is my left endpoint? Nope, the left endpoint would be at 1, right?
Yeah.
Yeah, my value is -3. Yeah. So it's f of, so it's going to be f of 0, right?
Yeah.
Does that make sense? I'm not contradicting. You were just saying the value already, right?
Yeah.
Okay, that's good. So now the next one. So it'd be plus, right? because I'm adding the area of all this. So the next one's going to be, what's my delta x again? 1, right? Okay, so it's going to be 1 times f of, what is the left endpoint here? 1. Plus, what is my delta x here? F of left endpoint plus delta x times f of 4. There we go. Kind of scrunch it all in there. Thought I had more space. Anyway, all right, so let's see. So 1 times f of 0. So that's going to be 1 times f of 0, which we said was, what is it? -3. Plus 1 times f of 1, -2. Plus 2 times, right? What's f of 2? 1, right? Plus 2 times f of 4, 13. So I have -3 minus 2 plus 2 plus 26. Yep. All right, so what is my total area going to be of this? 23?
Yeah.
Okay, yeah, 23. So our area is going to be 23. Because down here I get a negative area. Up here, a positive area. Make sense? Okay, so if we're making this all the time, then you could actually see what, where, and why. Especially when you get something where they are not equal intervals. Okay, this next part. Next part says use the what? Midpoint. So midpoints kind of suck, but they're important. All right, to find the midpoint, okay, it's going to be midpoint in between those two. But for this one, my delta x is going to stay the same. Delta x stays the same because it's still a rectangle, right?
Yeah.
Okay, so it's going to be 1 times f of, what would be the midpoint in between 0 and 1? Okay, f of 1/2, right? Yes?
Yeah.
Yeah, midpoint would be 1 minus 0, 1 minus 0 all over 2, right? Okay, it's the same thing for the rest of it. Okay, so it's plus the next one. My delta x is going to be 1 times f of, okay, so it's going to be 2 minus 1 over,
That would be 2 plus 1 over 2.
oh yes, so I'm sorry, 3/2, right? I don't know what I was thinking. 3 over 2. Plus, my delta x is 2 times f of what?
3.
Plus 2 times, keep wanting to do that, don't need it, f of 5. Okay. So, calculator, because I don't want to do the fractions. Do you want to do the fractions? Okay. Anyway, so it's going to be 1 times, it's 1/4 minus 3, 11, negative 11/4. Yeah?
Yeah.
Okay.
Yeah.
Okay.
That's correct.
Plus 1 times
Correct.
27 minus 12 is 15 fourths. No, 9. Oh, crap.
Yeah, over.
No, I'm sorry. Yeah, I don't know. I cubed it. Minus that's negative 3 fourths.
Yeah, negative 3/4.
Plus 2 times, that one's going to give me 9 minus times 6, and then plus 2 times 25 minus 23,
Yeah. Which
22.
Oh,
22.
dang it.
All right? 25 minus 3?
Yeah.
Yes. Yes.
Is that you, Pacho?
I think so.
There it is. I recognize you.
What's going on?
Hey,
It's 105 over 2, or 52.5.
Okay, so the total, you summed it up already?
Yeah.
Oh, good job. So you said what? 105
over 2, or
over
52.5.
Okay. It's a lot different than what I had last time, right?
Yeah. Yeah, like we should do the right.
Yeah, that's way different, isn't it? So on this one, so what are you thinking about the two values then? Think about accuracy. Which one do you think is more accurate?
The midpoint, because it's closer to the actual graph.
Midpoint should be closer to the actual graph, and so if I were to just graph those few points right here, just those few points right there, right?
Mm-hmm.
Yeah. So that one is of my left endpoint. The right endpoint would be a little bit better because it has a little bit under, a little bit over. So that midpoint should always be closer. That's all I'm trying to say. All right? Make sense?
Yeah.
Okay, good. All right. Approximate definite integral using Riemann sums, left Riemann sum. Okay, by partitioning into 4 subintervals of length 2. So to figure out the subintervals part, we would always go from 9 to 1. Okay, so insert page. So it'd be 9 minus 1 over 4, which is going to give me 8 over 4, which gives me 2. That's where I get my 2. My delta x is going to be 2 here. Okay? So I'm gonna make the equation out of this. So if I make the equation, I'm gonna have, let's see, let's back it up. 1 to 9, x minus 3 squared dx. So my delta x, or dx in this case, is going to be 2. So I'm trying to find the width. So I got the width now. So now I need to find the height of each partition of this. So my first one said we are going to do left, right, and midpoint. All right, so we're starting with the left side. So of this, if I'm starting it from the left side, let's look at my intervals. So my intervals are starting at 1, right? Where's the end of my first interval? 3, right?
Yeah.
Okay, let's keep going. And it's 3, 2, 5, 2,
7,
and
7, 9.
that's important to have. You know what we're talking about here, right? So I know that when I do this, it's going to be the left endpoints for all of these, right? So I'm going to make the function out of what I have right here. Because each one of these is going to be little rectangles, right? And they're all going to be base times height, right? Yes?
Yeah.
And all the bases are going to be the same because these are equal length. So it's going to be, I'm going to call this my delta x here. So delta x times f of
1
plus delta x times f of
3
plus delta x times f of
5
plus delta x times f of,
7.
there we go. They all have a common factor, right?
You could just
They all have a common factor, don't they?
yeah.
Okay, good. So if they all have a common factor, could I take it out?
Yeah, there.
It would be a delta x times, I'm going to bracket this, f of 1 plus f of 3 plus f of 5 plus f of 7.
Yeah, I remember this.
It's not bad, right?
No.
The trap rule is a little bit better to try and make this. This is just a little rectangle. So it's not really that hard to actually go through and do, but we're building to that point.
Got a little bit of writing, that's all.
Yeah. So let's take a look. What was f of 1? So we plug in 1.
It's a 9,
9?
right? Right? No.
Plug in 1 to the function.
Yeah, 1 minus 3, negative 3 squared.
1 minus 3 is -2.
Negative 2.
Oh, dude! Oh.
Woody.
Negative 2 squared.
9.
9. You're German, right? No.
Four.
No. 9.
Oh, man.
You good, buddy?
It'd be like that sometimes.
Okay, 3.
For a second there, I was
What do we get?
Somebody else do it, man.
You got this one. You got this one.
You got it.
0.
Thank you. See, redeemed yourself.
When you said 9.
All right, what do we get for the next one? 4 again. And last one? 16?
That's important.
That's important.
Wow, you like even said, did I say 16 too?
Yeah. 16.
Wow, okay. Brain hurty. All right. So let me see. You got 24 times 2? Right? Okay. All right, so there was the left side. Let's do the right side. All right. Are we okay with this? I'm going to,
Yeah.
Okay, good. If you need to copy that down, just write down the, pause the video.
Do the
All right, so I'm going to right side this one. Right is red. All right, so it's going to be same. My 2, right?
Yep.
Okay, so it's going to be f of
Oh, 3.
plus f of
5.
plus f of
7.
plus f of
9.
9. All right, there we go. All right, so f of 3.
Well, that's your bread and butter, Andy.
You got
0.
Plus
There we go. 36.
I didn't math these. I just knew it from the previous problem, right?
Yeah, that was
Okay.
just do right. You need the right.
All right. So let me see. We got 20, 56, 112.
Whoa, drastically different.
I hope the midpoint is somewhere
In between this.
Yes. It should be in between, right?
Yeah.
All right. So, let me see. Let's clean it up at least.
Oh, what was the first answer?
48.
48.
Yeah.
So my delta x is not changing for this one. Ooh, changed. Purple.
This is the F.
There we go. All right, so it's going to be 2 f of, all right, midpoint. What's halfway in between?
2
Plus,
F of 4
plus,
F of 6
6.
plus.
8 F of 8.
There we go. So 2 f of 2 is going to be
20
plus,
1
plus,
9
9. There it is.
plus.
35.
So it's going to be 2 times, is that
11, 36.
10, 36, 37? Is that what it is?
36.
36. Okay, yeah, 36. I counted that one twice. All right, 36. So it gets 72. Unit squared.
Yeah.
Okay, not too bad, right?
It wasn't bad at all. Just
Yeah.
All
right.
right. Basic math.
I messed up.
A lot of that. Okay, so concepts that you have to know. Guaranteed definite integrals exist. Define the integral from a to b of f of x dx. We assume that a is less than b. To remove this restriction, we give the following definitions. From a to a should give you 0.
Because there's nothing.
Yes, because it's top minus bottom, right?
Yeah.
Top minus bottom, so it should give me 0. So the delta x comes out to be 0 because there is no change from a to b, right? Yes?
Yes.
So delta x equals 0. So I should always get 0 on that one. 0 times any function is going to give me 0. Yes?
Yeah.
Okay, good. If a to b, if a is greater than b, and if, right here, the function exists, then we could actually change it up. So we could actually change our from where to where. So we could actually, it's going to be opposite, so it's going to be a negative value. So it's going to be a negative b to a of that same function where this still has to exist. I can't think of a problem in which that it would not exist. If it exists in the first place,
I mean, that's,
changing it backwards would,
would have to work.
it should, right? And so,
I'm sure the AP test would prove me wrong.
I know, right? Okay.
Is that, that's everything?
Yep. Do your homework.